sure. And you give me a signal that we can proceed or begin the session.
Yeah, we have started recording. We are just waiting for 2-3 more minutes.
Yeah,
So
yeah, sure,
that,
sure, sure.
you may join. Yeah. Till the time we are waiting for people to join in, Sumit, do you have any questions for Mr. Rajkumar?
Sumit had asked me, sorry to interrupt,
Yeah. Yes,
he had
yes.
asked me to print. So I'll print it because I was too busy in my daily routine, but I'll take time out and print. I hope I have that data which he has sent by mail. Normally I have the mail memory, so it should not be lost or destroyed.
Okay.
So I'll print those data which he had given. Of course, it would be in Cobalt Chrome.
Yes, it's okay.
One more thing I want to ask is that we will be seeing this in ExoCAD. So what about the implant studio version with CAD cam, which you were saying that you will give?
I'll be giving a demo of that. How
Okay.
to construct the CAD designing of implant processes. So I'm showing some versions.
How fruitful is it to buy those modules?
You see, it depends on Dr. Sumit. I would say that if you have some appreciable number of jobs to be done for implant restoration, then of course it is fruitful. But if there are very rare, then you can just take pay per use kind of thing. That if it is not so common and it will not be used often, then better to go for a pay per use kind of option of implant studio from 3Shape.
Thank you.
So basically you use ExoCAD only for most of your things. So ExoCAD is an
Yes,
open
yes.
platform where
It
you
is,
can use any type of denture, complete denture, implant
yes,
with denture.
yes. We can use almost everything. ExoCAD is very user friendly, and maybe we are more accustomed to it, so we find it more user friendly. But otherwise, I have taken opinion from other my lab fraternity people. They also said more or less it is quite user friendly.
Okay. So ExoCAD may also be used in designing of facial prostheses as well. So it's open platform. So
yeah, it is quite open platform. The facial scanner, they come with certain kind of thing, certain CAD options. But after that, we can switch to ExoCAD, and then ExoCAD allows you to construct the smile profile. See, we have the information of the lip profile, the face, and whatever the texture, the contour suits on the patient's mouth digitally. We can construct, and more or less it is too good. I mean, it is quite accurate.
so apart from dental also it may be used, or it's
I'm afraid I think my knowledge is limited to dental.
dental
For
only.
other surgical intervention and that reconstruction, we need to confirm with them.
Okay, because what I see here, ExoCAD showing all the teeth only. So I think this is dental version of the ExoCAD.
Yes, it is a dental version, but you have a DICOM version also to see that DICOM file of CBCT.
Okay.
And you can plan with ExoPlan, you can plan the surgical template, but I think it is again limited to that.
Okay. Yeah, I think we can start now. Yeah, there was any question?
Yeah, is it freely available, or we have to purchase the ExoCAD versions?
Can you repeat, sir, your question?
Do we have to purchase different versions like the DICOM version for ExoCAD?
Yes, you have to. You need to. Officially, whatever modules are available, you have to buy.
Please share the person who is dealing with the ExoCAD.
Yeah. ExoCAD I can also provide. That's not an issue.
Okay.
So we begin.
Yes, please. Yes, we may
with
start.
your kind permission.
Yes, please.
Okay, thank you. Okay, so this we are at the order stage, and what I will do, the scan data which I'm going to use, normally we scan and then switch to CAD designing. So we will first see the model. When we scan, then we have all this information available. So we just test model and we open the Exo viewer and we transfer this.
Is something happening on your screen? Because for us it's frozen.
Oh, you don't see my screen now?
No, we just see the first page, date, client name, technician.
Okay, but okay, let me just see if the sharing is limited to that order page. Wait, your screen is paused. I see the resume share. You see it now?
No, in that case you may stop sharing and then resume.
Okay, resume maybe okay. Okay, I stop sharing. Then go to sharing again. And I think it shows just one page only.
Yes.
That is the concern.
Mm.
Do
Yes,
you
now
see this model?
we can see this page.
So I think I have to keep switching every time I open a new page, maybe.
Okay.
Um, I'm also not very familiar with aspects of this
It's okay.
technology.
It's okay.
So just forgive me for whatever glitches are there, small glitches. Okay, so we study the model. We see where are the implants placed. So because this is critical to taking order. So this is perhaps order lower left 4, then 3 and 2, and then 1, then 42, and then I think 45. So according to this, we take the order. Now, is my screen shared?
Yes, yes.
No. The order page?
No,
No.
order page we can't see. We
Okay,
can see
okay,
the only
okay,
the model page.
okay, 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 okay. So, okay, we stop here and share again. I choose. Okay. So every page I think I have to manually choose and start
Okay.
sharing. So then we are here. We take the order with the name, maybe demo for KGMC and implant prosthesis and my technician. My name is this number, and here we are. Mm, better we choose 5 maybe, and we go for a reduced wax up. I'm going little slow to comprehend. And here, if we are choosing first custom abutments, so we choose a custom abutments in the order. Material non-precious. Scan a pre-op model, no. Gingiva, yes. Scan wax up, no. Design wax up digitally, and design virtual gingiva, that is on the wizard mode. So these are the orders, uh, very important. When we choose, everything comes according to this. And we hold control and press 1, then 42, and I think 42 and 45, and probably we can take this 44. Then we take this as a Pontic wax up. And we save the order selected. We proceed to designing. Now here we have to browse for the file we have kept on the desktop, scan files, and 610. Then we chose this model. I think I went wrong. I'm sorry. I made a mistake. Anyway, we go with this and load jaw scan. This is our jaw scan.
Again, we are on the
Sorry.
first page only.
Okay. I share it. Okay. Wait. Yeah, we knew that we have to do it manually. We have to switch.
Have you opted for share screen option of the entire screen or the page or the window?
Page. Where is the screen option? Share
This.
computer sound. Okay, optimize screen sharing for the video clip. Just see if you see my screen. Wait. I'm still Rajkumar. More. Okay. I have optimized for the screen sharing, doctor.
Okay, but
So
it's something is being loaded. I think it's taking some time to load on the screen.
maybe.
Yeah, because at present it's all black or
Mm-hmm.
gray.
Okay.
Not yet.
Mhm. If it doesn't go well, then maybe we choose individually.
Okay, I don't think it's something. Anything is coming.
Now,
First page.
okay, we are on the still on the first page.
Yes.
Okay. Okay. Then wait. Does it come now?
There's a page where you see all your files, I suppose.
Yeah, I'm seeing my files, correct. So we are on the right page. Okay, we'll individually choose then meanwhile,
Hmm.
because our time is like everybody joined in, so their time is precious. We have chosen the lower jaw first, then lower jaw as a marker, and then it is asking for gums, gingiva, and here we are. Now it asks us to determine the path of insertion. So this we assume is a path of insertion. We go to the next. Now start smile creator. This smile creator, doctor, as you were discussing earlier,
Yes.
according to the facial information we have through camera.
Okay.
Okay. Now for the implant to choose, we go into the implant library which we have loaded in the ExoCAD. So we can load from time to time for the newer and whatever implants come. We need to have their STL library. We are at ZFX. So I quick go down to ZFX and our order is Nobel multi-unit. Now ZFX is the most premium brand of scan bodies in the whole world. Okay. And because their accuracy they guarantee for around 2 microns. So here we mark and fit. So this is done. We go to the next. This is for the 231. Then tooth 31 is done. Now next is 42. We fit. Go to the next. And last tooth. Is fit. Now after this step is complete, we can might as well eliminate few unwanted things at this stage. So first we eliminate jaw and we have this only gums area. edit mesh. Body this need to go, otherwise it will keep interfering in our CAD designing segment. And then we trim out the gingiva. Normally this is scanned data, so there are some issues with this, so we have to manually do it. Scan abutment. Now we have this to trim. Thank you. We invert and delete. Still some part is left. It looks okay.
Are you doing something or speaking anything, Mr. Rajkumar? Mr. Rajkumar, are you there? Okay. Okay. Hmm. Okay. Some internet issue. He is joining soon. Mr. Rajkumar, have you joined? Hello? Huh?
Is my audio on now? Okay. Doctor, one more thing. Do you see my screen properly?
Yes, we can see your screen.
Okay. Thank you. So we are. This is very useful. As I said, I am resuming from the point we left last time. I mean, I got disconnected. So this will determine exactly the color of the customized abutment according to gingiva. We go to the next. Suppose here there is no it is equigingival. Just pass and pass here to 42 and here as well 45. So now it prompts the CAD software a kind of anatomy that we could be working on, imagining. So we just try to bring it through chain mode, and this is how we raise the whole thing up, and we free from here and bring it onto the reach, the anatomies, and somewhere here we can bring it here, and we can go into the single, raise a bit. We have a kind of assumption that occlusal plane could be somewhere here. We just align the teeth, one by one, and if you approve that now it is in my scheme of things, it is in my scheme of things, go to the next. Now here it prompts two types of subgingival custom abutment shapes. So this kind will have a little impinging effect, or there is a lot of gap between the abutment surface and gingiva. You can choose this, or if there is a gingiva is constricted, you can choose one on the left. So you can slide this bar, you will get more of like this, and I mean sorry, you will get like this, or if you slide here, you will get more like this. And margins, if we are making custom abutments, we want the collars to be defined, so we can just push control and we can have enough resting collar for the prosthesis. So we can do one by one. This I usually do it very commonly, because then it helps me have enough collar resting place. Otherwise, you don't have a defined collar. So that is again very dicey. And we can individually again design the teeth what we want. Suppose we find this more tilted lingually, so we just bring here. This is for a show. It may not be tilted, but just to understand what are the tools we can use to change whatever is required. It's more of a understanding of your armament. Then you can adapt to gingiva. Now it is adapting to the gingiva by a simple cut. You can see by hiding the gums, it is free from any interference onto gingiva or onto uh, jaw. You can just make it transparent. You can see there is no excess impingement on the gums, the entire ridge, maybe gingiva or the soft mucosal tissues. So we go to the next. Now it is asking for cut for intersection. I just give you a small example. If you have a excess in here, and here we can see the excess, we just apply one. So all the teeth, the proximal side will be adjusted by cut intersections. And this was for pontic and this was for the proximals. Now we want all in one direction. Or rather we choose for all custom abutments because we want parallelism in all abutments. So we just join them. Suppose you want individual path of insertion, then it was okay. But we want all join. Now we set the insertion view from here. Okay. So you see all in parallel to each other. There is a proper parallelism. Now you can shift entire, you can see all moving in simultaneously. The path of insertion is common to all. So when we make a processes, if it is a splint processes, which usually is, so it is in perfect parallelism to each other. We go to the next. Now this is given us some expected height as per the tooth design. We can increase or decrease. We can increase, so this becomes like this, and we can increase the height or decrease. So whatever required, we can manipulate here with the abutment outer surface design. Same here. Okay. Now we can hide the anatomy and we can see now this is extra sort of undercut, but it's okay. It's quite acceptable. If you see from one insertion direction, there are slight undercuts, but it is quite acceptable. Or we can still do some surface smoothing. So we can remove this undercut, not a problem.
What is this color code being used for interpretation?
This is showing the undercut. We are trying to remove this undercut because this is little bit of divergent angle of implant. So it is reflected on the abutment also. Trying to minimize this.
So is it something like stress or it's just the undercut? Means how does the software
No,
do it? Huh?
I mean it is doctor showing the ExoCAD is trying to show us that this area is sort of undercut. So if you smoothen this, this would be good enough. Okay.
Yeah.
Now we go to the next. We can still try and see if we can orient the angles. Path of insertion. No. Now here this is because it is trying to bring in parallelism. So that's the whole issue about it. We can try to manipulate a little bit, not much, because we have to preserve the access hole of the screw. So we cannot go into that critical area. We're just trying to bring it as much as possible. Now it is recalculating, and this is customized parallel abutments. Now here problem is we cannot reduce this area. This is secured area for the implant access, screw channel access. So cannot be interfered here. So this is a sacrosanct area, unfortunately. So this will not allow. Uh, at the moment when the abutments are milled, we can just trim it down. But if we trim it down, maybe the screw head could be seen and may not be very preferred kind of thing. So this is about customized abutments, and we see those abutments. How are they looking like in Exo Viewer? Abutment 45. This is how it is. 42. And 31, and we can just hide. You see the connection surface of abutment?
Yes, we can see.
Yeah. So this is a connection surface, and the screw fitting area, screw head. This is what I was talking about yesterday, that if you zoom in, you see the screw fit area with perfect right angles as per the CAD design. So many times with the print, unless print is too accurate, you may end up this curved area. The screw fit edges will be suspended somewhere here in the curved area. So that is a problem. That is why they customize and sell their screws, and which is not very good clinically and scientifically. So, and this is your Abbott model. Now we go for prosthesis design if necessary. Okay, remove all. We open the order page. We design the prosthesis. Now prosthesis can be in form of reduced metal substructure, a framework for ceramic layering or composite layering. So we quickly design that. We load the scan file. I mean the whatever data we have prepared so far, we can continue from there. We increase the cement space because undercut is there. You can see this doctor undercut. This
Yes.
is a nasty undercut, so it is leaving the margin open. I'm worried for that, but let's see how to address that. Maybe in abutment, we can fill up some material and increase the diameter of the collar. I hope I can explain properly. So we want to eliminate any chance of the superstructure seated, and there is no gap beneath for the cement, for the excess cement to come in. So we can do it some kind of Indian jugaad, that we widen the diameter. Okay. Uh, Next, you can appreciate the divergence of implant positions, doctor.
Hmm.
So this and this, the 44, the 45 and 34
Yes.
among the mutually divergent angles. Now
Yes.
it is calculating. I think yesterday, maybe in 10 minutes, I would have to hurry up, and the computer was also not supporting
No,
so
it's
well.
good. It's for good.
Yeah, so at least peacefully we can share the information among us.
Yes.
The calculation does take time, but it's okay. This step will design the bottom shape, and okay. Now this we can mark. Now it is creating a gingival profile. This I by error it went in, so I will have to recalculate the gingiva. Apply. It will recalculate. Now it is almost done. Here we are. We can pull up gingiva as required. Okay, this is going to interfere the screw channel, but we have to accept it as it comes and just smoothen it all over. Smooth the gingiva. We apply a shrink, thimble crown shrink. We can place the crowns abutments. Now here is not much of scope, so we just accept it as it is. We can pull up the gingiva as per requirement, but I think this we don't have much of scope, and this we can, okay, fine, we accept it. And next, free form gingiva. Here we are. We are trying to cover the extra margin area with gums, and this will be finally covered. Earlier we used to do with the titanium porcelain, because this material is milled in titanium, but now beautiful range of composite materials are available, so we can cover the gingiva part with composite. This we can just remove. And here we are completely, whatever has come onto gingiva, that we just remove. Everything looks little convincing, and okay. Now finally we just correct the heights of the, now this height I'm not happy about, so I can just pull down the height a bit. Okay, now finally we just be about, so I can just pull down the height a bit. Okay, here we are. Now sharp edges should not be there, whether it is zirconia or whatever material. So we can just slightly smoothen this. So we can provide a better surface for the superstructure to come. Now I see here this part, we'll just quickly remove that also, but we correct the sharpening of the smoothing of the sharp edges quickly. Now only this area was a matter of concern, so we just smoothen it. Okay, and we are almost done. I think, yeah, here it was. We just remove this. So this is like a papilla which it will serve as a papilla effect in the final restoration. And now papilla, even if it is short, we can correct with the composite. So that's a beautiful advantage.
I think your screen is again stuck.
Oh, is it? Uh, yeah, I can see the screen is not sharing. Mm, okay, I have to log in, doctor. I'm afraid. Log in
Okay.
again.
Okay.
Yeah, here it is. Uh, share screen. Your entire screen. Uh, is it seen now, doctor?
Yes, we can see your screen. I see my picture there.
Okay, doctor. Okay. So, uh, here we are. Now you can see, doctor.
Yes, yes, now we can see.
Okay. So whatever we want to do, we can do any corrections, modifications at any stage. Now this height, I feel it is little more. So I can still change by going in expert mode and height. So whatever we feel that this needs to be modified, it can be done anytime. It's not
Yes.
a problem. That is why we call this as a very user-friendly software, because it allows you to satisfy your creativity. It's not that, oh, it cannot do, because sometimes in some software, CAD software, you have so much limitations. Okay, and here we are. We go to the next page. Uh, this is you can like bring in the margin or out, whatever, or you can just undo it. I'm happy with the previous version. So this is how it is. So one by one, it is marking the margins. Now here it is confused because the cat doesn't find this to be a normal tooth. But anyway, we go to the next. We can anytime modify or edit the margin, doctor. So in one step, I could show you the custom abutment and the Malo bridge cementable. But if we choose the order differently, I have to design it. This is where the CAD is confused. He says, "Hey, I don't understand. What do you mean?" So we are just guiding the margins, the software, that please place your margins, or we just simply clear and we draw it. because editing will take time and drawing will not. Here it is, new margin. We go to the next. Now it has a base ready. It's calculating everything. And you can see, doctor, the teeth numbers, all teeth numbers. And on the top is showing the abutments numbers. You can see the copings and what was seen earlier, orangish, brownish, that is cement space. Okay, this should be the margin. Okay, accept it, no problem. So the calculation, it is calculating for cement space also, whatever the assigned cement space for the superstructure. Okay, this is the last one, and here we are almost done. Now, if we want the Malo bridge as one piece, so we could have chosen here when we take the order, for example, 34, we could have chosen as screw retained. So everything will come as one piece. So this is just to highlight that when we chose custom abutment, there are two pieces. One is a basic custom abutment, and on the top is two stage of processes: the malo, which is cementable on custom, and third is a final crown. So here we are. Now it is showing in shadow the copings. Now if we choose zirconia crown, fine. We can choose Emax, that is also okay. And if there are anomalies, both zirconia and crown can be layered with porcelain. Now this area is, we'll see the screw channel. So this area might remain open. So you can plug it with something. If we are considering full crown, we have to work on this. Just add some material here. Maybe we screw tighten and then give some shape to this. Now this is a bit dicey. Just smoothen it. You can just pull in because it is too bulgy and cause some tongue thrusting. And here we just this is negative arch, and that is how this you can just pull it out little bit and then make it look little better. At the moment not happy with this. Okay, and this is how it is. We can make a reduced coping, so we can layer with the porcelain. All options are open. We can still do gingiva modifications if necessary. Okay, it is adapting.
Send the patient to trauma, sir. Do we need
No.
My computer is still little old generation because we need at least 32 GB and maybe i9 processor to have a good thing, fast processing. We make it 0 or we can reduce for ceramic layering. This is the depth of reduction. You can see apply, and we can layer with the porcelain. We can see how it looks. This is a reduced surface, and if we don't want, we want full crown, then just go on. So we have all the options open. This is the connections. I'll show one connection, how we can, because we don't want connections to be seen, you can just pull them in. And individually in the connection segment, we can address this. Now it is calculating for the final. So you can view everything, abutment, the Marlowe framework. Now abutment Marlowe can be one piece. If we had selected as a screw retained, but we selected two piece just to show the custom abutments and also this. There is a lot of calculation to be done. Anything to ask about, Doctor? Meanwhile, hello.
Any questions from the audience?
Hello.
Hello. Anyone wants to ask
Hello.
anything? Is there any question?
Rajkumarji, have you ever tried to print the customized abutment?
I think we have lost him.
Hmm.
Hello?
Yes.
Rajkumarji, have you ever
Hello?
tried? Hello, can you hear me?
Hello?
Hello.
Can you hear me?
Yeah, you are audible.
Hello?
Hello. Hello.
He has connected through his phone data.
Can't hear. A moment, I think there is some issue still. My screen is it shared?
No.
It has started
Wait,
screen sharing, but
I
it's
wanted
not
to.
showing it.
Um, that is a very sad part of this
I think your internet connection is
entire
weak.
screen. Maybe, but I'm using a phone connection, so okay. Anyway, we will just. I'm afraid this is not working out so well
Hmm.
because we had some great things to share, but
Okay.
our bad luck.
Okay.
Huh. Dr. Sumit was asking something
Yeah, I was asking that have you ever
because
tried
I
to
attempted.
print the customized abutment?
See, printing is too easy. Only thing we have to ensure that the file sizes, the screw channel diameters are
Hmm.
correct. Because normally what I do, I measure with the caliper the screw head diameter and
Hmm.
the threaded part of diameter. So, and we check the STL file by measuring what is the diameter. So, if we can give a little bit of leverage, like compensation for the screw head to pass through, then I think it becomes a lot more smoother. And yes, the metal printer should be of accuracy of around 20 micron. Then still we can look to achieve that result, screw retained. Otherwise, it will be
You
a
have to go
tough
for
job.
milling. Hmm.
I still would say that go for a
Milled
milled
option.
version, milled option, because milled gives you, yeah, milled gives you, we can run the end mill tools with sharp
Hmm.
edges tools in the screw fit area. That is one, and we can have the screw channel exactly according to or conforming to the diameters we want, so that we can adjust in the milling side with altering the milling templates. By the
Okay.
way, I did not share. I'm also application specialist on the Hyperdent CAM software.
Yeah.
So because of my that knowledge, I can
Hmm.
manipulate anything that we wish to in machining side or designing side or in the designing the milling templates.
Actually, I was wondering to see the Hyperdent software as well because and to compare with the CAD one, the which you are
Hmm,
showing. So
hmm,
how
hmm,
the
hmm, hmm.
Hyperdent software is better than that? Okay.
Hyperdent is a milling software, as you know, and
Yeah.
it see, everything is a game of running a specific tool on a specific area to
Hmm.
achieve a specific result. So it is all about milling. So we
Hmm.
can choose a tool, the milling burr, as you can call it, milling
Hmm.
burr with a special surface. Suppose we are milling the undercut area, or for example, we have to mill a angulated abutments
Hmm.
where we can approach the access hole up to 25 degree.
Yeah.
So from the threaded side, the connection side, and the top access hole side, there is some
Hmm.
angulation of 25 degree. So it is
Hmm.
just a matter of running a proper tool. It is called as a T slot cutter. So we can run
Hmm.
that and achieve that. So similarly, if we design a bar and we want
Hmm.
to hold on some superstructure by telescopic version, or should be some kind of undercut. below. So we
Mm.
can run this special lollipop tools. So I'm just trying to uh, put a broad perspective of whole thing, that you choose a tool for which
Mm.
you want to mill a surface, and then you run specifically in the milling software, and if machine is good, you achieve amazing results.
Okay. Thank you.
Hello.
Hi, thank you. Yeah.
Mhm. Uh, I think it might be appearing little at this moment little boring or too much of activity. So, but I still thank you for all participants who have taken time out, and but I think it could be if the internet was better. I
Yeah.
only feel bad and embarrassed.
No, 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 no.
Then our presentation would. I
Yeah,
wish
that's
it could have
why
been much
that's
more
why
smoother.
you always wanted to put videos.
Exactly, that was the precise reason, because in live presentation you encounter so many difficulties,
Yes.
but it's okay.
But
That is
it's
how
okay,
we
yeah. Yeah.
understand.
We got a good
Yeah.
visualization of how you do things. So thank you so much, Mr. Rajkumar,
Yes,
for
doctor.
joining us and
Th-
sharing your
Thank
experience.
you. Thank
Yeah,
you so much.
thank you. Thank you so much.
Thank you, doctor. Thank you. Bye bye.